Hi everyone, welcome to the Mathemagic channel. Today we look at how we can solve the integral of ln x divided by x. This is a problem typically that you'll encounter when you're doing calculus at higher level, so perhaps like IB or A levels or APs. Let's jump right in. So this problem is a little bit interesting in the way that it's not a very long question, but it's a question where typically when you use integration by parts and you fall onto what we call a cyclic integral, this will have to do with cosine or sine or exponential, but we don't often see ln x being part of a cyclic integral. So this is why this is pretty unusual and a little bit interesting. If you appreciate integration by parts, you'll enjoy this question. It's definitely an interesting little one. So the first thing to realize here is that we have a quotient, the quotient of ln x, and we have 1 over x next to it, so you could say it's ln x times 1 over x. And so we're going to need to use the integration by parts formula here, which is really like a reverse product rule that we rearrange. So you'll notice in the integration by parts formula that you have the integral of u dashed v, which is equal to a remainder uv, so the two original functions, minus the integral of v dashed u. And so the best thing to do here is always to think about picking u dashed to be something that you're quite comfortable integrating, and picking v to be something that you're quite comfortable differentiating. And so ln x is not something that's easy to integrate. I mean, it has an integral, which is x ln x minus x, but we don't typically know that. We don't typically use it very often. However, the derivative of ln x is 1 over x, super well known, super easy to use, so we're quite happy with that. So we can set our v to be ln x, and it'll differentiate nicely to 1 over x. For u dashed, we can set it to be 1 over x, and it'll integrate nicely to be ln x. So it seems like a perfect world, and there's definitely just one very clear direction to go with this integration. So we'll first say that it's ln x times 1 over x dx. We'll say that that's equal to the integral. And then we'll set our variables, so going in that direction where u dashed is 1 over x and gets integrated to ln x, and where v is ln x and gets differentiated to 1 over x. So all seems pretty good there. And so if we look at our integral, it's the integral of u dashed v, and it's equal to a remainder minus the integral of v dashed u. And so the two integrals, so the u and the v are going to be ln x times ln x, which is really just going to be ln x squared. And you notice in the second section that you get minus the integral of ln x over x. And you're kind of stuck here because it's supposed to simplify and become easier, but really we just landed with the same thing. So what do we do? Well, this is why this is a kind of unknown cyclic integral, because we do this a lot with cyclic integrals with sine, cosine, and e to the x. This is like common practice, but we don't often see this with ln x. So we can actually say that the integral is equal to ln x squared minus the integral. And this is super cool because now you can move the minus integral to the left and say that we have 2 times the integral is equal to ln x squared. So this is a very clever little trick here. And therefore the integral is actually equal to ln of x squared divided by 2. And don't forget to add a constant since it's an indefinite integral and we don't know how high or low it's floating above the x-axis. So if you're doing calculus and you're studying integration by substitution or integration by parts, I hope this was useful to you. Make sure you like and subscribe to the Mathemagic channel. You've only got a little bit to go before you go to university. If you're an adult and you enjoyed this question because you still like mathematics, make sure you like and subscribe to support our channel. We always like putting out math content. We'll see you on the next one. Bye-bye.